Yeah. Hey, everybody. Thank you very much for showing up. It has been a long but very awesome conference day, and now you can sit back, relax, and enjoy this case study of our virtual fashion pipeline. Let's see if this works. Yeah. So virtual fashion is a very broad term, but first and foremost, when I talk about this, I mean bringing garments and clothing, but also accessories like shoes and helmets from the real into the virtual digital world and create 3D representations of them. But besides creating pretty pictures and viewing them from all angles, there's a lot more you can do with it. You can do virtual try-on, you can do mix and match of outfits, you can do a size recommendation, and you can even do virtual fashion imaging. And I will touch briefly on most of those in this talk. But first, let me introduce myself. My name is Philipp Gosch. I'm a technical artist, currently working at ReactiveReality, where I'm most of the time coding our own custom real-time render engine. But I'm also the local Blender expert, so we're using Blender in a lot of places, in a lot of different departments. And whenever there is some questions, issues, or we need a feasibility study, can we use Blender for that? People approach me, and I really appreciate that. Besides that, I'm doing a bit of freelance at my own homepage, Sapphire Studio, and I'm part of the Sketchfab Masters team, which I'm still really proud of. And feel free to connect with me on your favorite social media of choice. So this is what I will be which I will be talking about in this talk. So let's jump right into it, the overview of virtual fashion and the use cases for it. So generally speaking, the fashion art is currently thriving. If you go to ArtStation and search for clothing, garment, or virtual fashion, you get a lot of really awesome artworks that artists created, uploaded, rendered, and animated. So I definitely urge you to do that. It's just very beautiful to see. But there is another point, which is using virtual fashion to actually help fashion companies and fashion brands in the different stages of their production, where it is really helpful to use virtual fashion. So you can do, for example, do virtual prototyping, where you can test the look of your garments before ordering fabrics and manufacturing any of them. You can do virtual photography, which is an area where you can combine model photos or 3D models with different garments and use that for product shootings or marketing without doing any real photo shoots. And of course, in the end, for retail, you can do a virtual try-on in webshops. You can do an omni-channel presence where you have a brick-and-mortar fashion store, and you put some magic mirrors or iPads or whatever there, and people can do a virtual try-on before going on and actually ordering at the store the garments, fashion clothing they decided on. So that brings me to the virtual fashion pipeline we have established at our company, ReactiveReality. Let me introduce the company real quick first. We're a fashion tech startup based in Graz, Austria, where I'm also from. We have offices in Graz, San Francisco, Paris, and Tokyo, founded in 2014 and around 60 employees. And we're working with bleeding-edge fashion technology. So we're using a lot of artificial intelligence and machine learning to enable the creation of virtual fashion at scale. This means that a fashion brand can approach us and say, we have a collection of 10,000 individual items, and we need optimized 3D models of them as soon as possible. And then we go and say, yes, we can do that. So here's a short video about what we are doing. So first and most obvious use case, of course, is having 3D models and representations of the garments and clothing in a web store. Then here you can see the virtual try-on, where users can try on different combinations of outfits when shopping online. We try, and we do actually digitize a lot of different garments. This is an important part where users can create a 3D avatar of themselves by just simply taking a video or selfie with their smartphone. and then use this 3D avatar of themselves to do clothing try-on it. And as you can see, we use Blender in our official marketing videos. That's how much we love it. And a lot of our input is based on photogrammetry scans. I will talk a bit more about that later in the talk. And you just saw our photogrammetry studio. And yeah, that's basically what we are doing. So our technology runs under the Pick-to-Fit name. And there are mostly three big groups of products. We have the capture kit that I've just mentioned, which is used for photogrammetry captures of garments in an automated fashion. Then we have a content service, which we use for managing all the assets, all the clients, all the iterations, all the different parts and processes of creating the garment. And we provide a software development kit to our clients, which they can use to integrate all the functionality we provide, like size recommendation, virtual try-on, and so on and so forth, to integrate into their mobile apps or web apps. And this is how our technology stack looks internally. So we have different sources where we are getting our base data on, and I will talk about this a bit more in detail later. And then everything is fed into our content management system, which is basically a big database of all our assets, all our garments, all our avatars, all our clients, all the collections of the clients, all the different iterations of the assets we are doing, and so on and so forth. And we have a convenient web interface to work with all of that, and it's integrated with the different other technologies we are using. Then we have a content delivery network, which is accessible for the clients, and there they can download the textured 3D models or the rendered image or whatever they are expecting from us as an output. And of course, there's a SDK that can be integrated from the clients into their iOS, Android, or web presence, or using Shopify, or whatever technology the client actually prefers. So let's get to the meat of it, how we're using Blender. So yeah, this is the basic sources for fashion data we can get. We can have photogrammetry data, CAD data. It can be modeled and textured manually from concept images, of course, or from photos. And it can be 3D data generated by an AI. So one of the most common ones we're dealing with is photogrammetry. So we developed a capture kit, and the setup you can see here, it's 3 cameras. It's 4 actually nowadays, and light sources. And there is a turntable which is connected to the other part, and which is automatically turning the mannequin with the garment, taking photos, and the photos are automatically uploaded into our content management system, where there are some pre-processing and photogrammetry is done. As software for photogrammetry, we are using Zephyr 3D, but we do a lot of custom post and pre-processing to all the images and the 3D data we get out of that. Then the other big way how fashion data usually in the fashion business is created is by using specialized tailoring software like Clothes3D, Marvelous Designer, Browseware, and some others. This is actually software aimed at dressmakers, tailors, which are actually creating the fabric patterns, and then they have a 3D editor where physically simulated 3D sewing is performed. And if you want to try that way of creating fashion, yeah, I can recommend these 2 great add-ons. I'm in no way affiliated with them, but I thought I should mention it for those who want to try creating virtual garments themselves. They're really great. So we also have a team of skilled 3D artists who are very versed in creating virtual fashion. And they mostly do a final check of all the 3D meshes and textures we get out of our automated tasks. They're starting and initializing processing or new iterations, but there are also just skilled 3D modelers and texturers who are fixing sometimes common and sometimes completely one-off errors in the data we get and process. And there are errors. While the automatic ways work really well nowadays, it still happens that something goes wrong, and our 3D artists have to deal with it. So depending on what input method and what processing we use, we have other set of issues we look out for, especially. And I will show you some of those issues. A bit of warning, I call this the gallery of horrors for 3D artists, because now you're seeing mostly mesh and texture issues and errors. So this is one most people who have used photogrammetry probably know. Lighting information is in the texture, everything looks nice, and once you go into shaded view, or you do a relighting, which is the actual problem, then you see that the mesh is completely off and needs to be fixed. Then we have weird topology, cases like this, where two holes are connected and everything is just supposed to be a flat surface, are especially nasty because they still could technically be watertight and manifold meshes, so it's hard to look out for them. Then there is, of course, the floating geometry, which doesn't belong anywhere. We usually don't do that anymore, but we had to do a lot of detail removals. I hope you can see that, where the buttons here and this part have been removed from the mesh because everything, every bit of information that we need was in the texture already. Then, as usual, normal issues. That's not a fancy new fashion style. That should be a plain gray T-shirt, which actually has normal issues. And then this is a UV layout you could get out of photogrammetry software. Yeah, it happens. And I guess everybody can see there's a lot of potential to use the rest of the UV space available. Then you have mesh connections where you don't want them. They might be fine on static models, but once you are fitting the garment onto a posed avatar, then the problems quickly become visible. And of course, there's missing texture parts. This happens especially often if there are folds in the garments and the photogrammetry software doesn't have enough information from the input images to create all parts of the texture. Then another thing when you're doing photogrammetry is you have take care of insides. If you're scanning items with two parts, like shoes, where you have the upside and the downside, which need to be scanned separately, then of course they need to be merged. And yeah, a lot of this stuff we noticed was reoccurring. So the same issues popped up time and time again. So we thought of ways to automatically check and fix for them, which brings me to my next point. The tasks we automated. Quickly checking the time. Oh, nice. So most commonly, to fix the issues, what could be done was, we fixed the topology, which is best done by simply remeshing the mesh. So it can be done automatically. If you're remeshing, you have a new mesh anyway, which needs a new UV layout. So might as well make that as clean as possible. And after that's done, we can rebake the textures. And we noticed if we do those 3 steps automatically, we can fix most of the issues I've just shown you before. So we came up with a way to do that automatically. And of course, we created a custom Blender add-on, so repetitive and tedious tasks can be taken off the shoulders of our 3D artists. We use a very powerful internal software where we do a lot of processing, a lot of preparing for fitting, working with parametric body model representations and stuff like that. And we realized it's really beneficial for our artists to have a seamless integration and transfer between Blender and our custom software. So whenever you are editing something in our custom software, you have an option to just transfer the asset seamlessly to Blender, do some mesh texture or whatever editing there, and then our add-on provides a way to seamlessly transfer back to our software and load the appropriate data We're using some custom file formats for that because we have lots of additional data information for the garments and clothing we're using. But we also provide GLTF and OBJ import and export. And yeah, we created an analysis and a cleanup tool, more or less, which our artists can use. We realized that most of the mesh issues can be found by the add-on that already exists and is designed for 3D printing meshes. So thanks to the power of open source, we could reuse a lot of those checks. Then we have a big part where we provide very custom functionality that actually comes from our C++ SDK, where we can do garment try-on, physics, seam and subgroup handling when we are dealing with CAD data. And this is made possible by our software development kit being provided with Python bindings, which means our whole C++ software development kit can be compiled as a Python module and just loaded inside Blender by using the command import Pictofit core Py, and all of our functionality is available inside Blender. And of course, this is extremely powerful, and our add-on makes use of that. So then we more or less have shortcuts for other add-ons. We're using the great UV Packmaster add-on for layout of UVs and the quad remesher for remeshing. And we're also running some Blender instances on server to do automated tasks, which is really easy to do and I can recommend. And as the last point of my talk, I will talk about machine learning data generation. As I've said, we're using a lot of machine learning to do very specific tasks and to aid the artists so that they don't have to do tedious tasks again and again and again. And that also enables the scalability we can provide for processing thousands of assets in a short amount of time. So now there is an issue with machine learning, because we want a machine learning model to do some task on a large amount of data. So a machine learning model needs to be trained, and to train the machine learning model, you need a large amount of data that's already labeled. So that's a typical dilemma with machine learning. So what can we do in that situation? Of course, we can use Blender and generate synthetic training data for us to train the machine learning model to then use on our real data. So I will show one example real quick. We have image classification for photogrammetry input, which we wanted to automate. So taking one input image from the cameras of our capture kit, we want to know which pixels belong to the garment, which pixels here shown in red belong to the mannequin, and which ones belong to the turntable. So we can do automatic mask creation and some more. So what we did was we created a virtual version of our photo studio and rendered image that as closely as possible resemble the input images we get from the cameras. But when we additionally enabled the object index pass, this already delivers us with all of the masks and basically the labeling we need to train the machine learning algorithm with that. So here you can see the digital version of our studio with the lights resembling the real light positions, and the camera is moved with a script. And this is a low-resolution photo of how our actual studio looks like. So you can see it's very similar. And this is a rendered output. It resembles the photos really closely, which was good enough for the machine learning algorithm. And additionally, we got ready masks corresponding to every render for the different pixel areas we were looking to classify. So we then added a script to do that automatically, and we varied some parameters, like the camera position, the settings, like field of view, where the lights are placed and how strong are they, and different environment textures to simulate different photo studio situations. And as a result, when we rendered hundreds of thousands of training data images using this approach, we got a huge training data set, which works so well that our machine learning algorithm doing that classification can could be trained, basically. So we are working on some more stuff in that direction currently and actually employing it. So for example, this is 3D model creation based on a single input selfie, nothing more. And that brings me to the end of my talk. Thank you very much for your attention. I will be around the venue if you want to chat and have fun with the following lightning talks. Thank you very much.